Hello, today we'll be going over an example of inverse mapping using little blue herons. Here we have an example of a heterozygous little blue heron with three alleles on one chromosome. These alleles are for purple or blue head, a long or short beak, and yellow or green eyes. How do we get our heterozygous heron? Well, we can cross two parents who are homozygous for both alleles. And if they're homozygous, we can be certain that this set of alleles will be passed on from parent 1, this set of alleles will be passed on from parent 2, and so this is what the chromosomes for our heterozygous heron will look like. There are 8 possible gametes we can get from our heterozygous heron. We can have 2 from no crossover, in which case it'd just be one of these sets from each of sister chromatids. We have 2 from single crossover event, in which the first loci is switched for recombination. 2 from a single crossover event, in which the alleles from the third loci are switched for recombination. And double crossover, in which the first and the third loci have been switched for recombination. We can now ask what probability of having a purple-headed, short-beaked, green-eyed gamete from this heterozygous heron would be. Gamete would be bLY. This would be a double crossover event. Here we see that if we take the chance of recombination for first allele and for third allele, multiply those together for a coefficient of coincidence, which is 0.9, we get 0.01458. We multiply that by half, since there's 2 possible gametes we can get from double crossover. And so our chance is 0.729% that we'll get a purple-headed, short-beaked, green-eyed gamete. Now let's ask what's the probability of having a little blue, little L, and large Y gamete. And we would get this from a single crossover 1 event, so just the first loci having crossover. And we take our 18 centimorgans, which means 18% chance of that recombination happening. Subtract that from chance of double crossover event. Then we multiply that by half, because that's chance of getting a single gamete from after the single crossover 1 event. And we can tell there's an 8.271% chance of that gamete being passed on. And here are the resources. Thank you for watching.